Okay, so what we're doing today is we're doing systems of linear equations. So this is what happens when we have two equations with two variables. We're going to have to solve one to help us get the other. Now the first one they want us to do is they want us to use substitution method and solve for y. So what we want to do is we want to take one of these two equations and actually solve them for x first. So I'm going to take this top equation. I'm going to rewrite it. 4x minus 20y equals 16. Okay? I'm going to solve for x. So I'm going to add 20y to both sides. So 4x equals 20y plus 16. Okay? Now I'm going to divide everything by 4 because, again, I'm solving for x. So this means x equals 5y plus 4. So what I'm going to do now is I'm going to take this x equals 5y plus 4 and I'm going to put it up here and I'm going to substitute it in where x is. So instead of putting an x there, I'm going to put this 5y plus 4. So that means this is going to be 4 times 5y plus 4 plus 20y equals 176. So now I distribute 20y plus 16 plus 20y is 176. Combine like terms. 40y plus 16 is 176. Subtract 16. 40y equals 160. So y is 4, and that means your answer is A. All right, over here for number 2 now. They have two different packages. All we have to do for this is set up the equations for y, okay? Two different packages, and if you think about what we did yesterday with linear equations, we just have to set up the problems. So for package 1, it's $349 for airfare, but it's $141 a night, so that the $141 is what's going to change. The $349 for airfare, not going to change. Same thing with package 2. Airfare is not changing, but the hotel room is $452 a night, okay? So if we go to set these up, for the first equation, $349 isn't going to change. The 141 is because it's per night. So if we say 5 nights, it would be 5 times 141. If we stay 3 nights, it's 3 times 141. So the 141 gets the x. So that's $141 plus, or times x, plus the $349 for the airfare. For the second equation, that's y equals, it's 452 a night, so that's 452x, plus the airfare stays the same, that's $233. So if we look at our answers, that's B. Now we go to 3. 3 is the same thing as A, but this time they don't want us to use substitution. They want us to use the elimination method. So what that is we have to eliminate one of these variables. Okay, we have to get them to where the number in front, the coefficient, is the exact same number. So for me, easiest one to get rid of is going to be y. Okay, so in order for these two y's to be the same, what you can do is you can just multiply 2 times 7 and get 14. So how did we get 2 to become 14? We multiply by 7, but that means we have to multiply everything by 7. So my new equation is 63x plus 14y equals 203. And I did that by distributing 7 times 9x times 2y times 29. How did I get 7y to become 14? I have to multiply everything by 2. So that becomes 8x plus 14y equals negative 72. Okay? Now, I notice since these two are the same, I can eliminate. The way I'm going to eliminate is I look at the signs in front. If the signs are the same, we subtract the top minus the bottom. If the signs were different, we would have added. So 63 minus 8 is 55x. 203 minus a negative becomes plus 72, and that is 275. Notice 14 minus 14 for the y's, it disappears. I don't need to put anything down. So I'm going to divide both sides by 55. X then becomes 5. So now I have to put x in for one of these problems. I'm just going to put it in up top. So that becomes, see, I'm putting it up top. 9 times 5 plus 2y equals 29. So 45 plus 2y is 29. Subtract 45 from both sides. 2y is negative 16. Y then is negative 8. And that answer is C. So what you guys have to do, systems of linear equations, you're going to do 4 through 10. And as always, wash your hands, save a life.